Hello, this is Mr. Hazipta, and I'm out today taking care of my son. He's got the flu. And so hopefully you all worked on your quizzes. You had a chance to look at the keys, work together, and kind of figure some things out. If you need help, come see me before school, after school here in the next few days. I'll be happy to help. At any rate, here's the lesson that you are missing on section 9.1 and 9.2. So we'll start with section 9.2 first, the translations, and then we'll go to the section 9.1 in a different video. All right, so when you look at section 9.2, it's we're going to study transformations this unit. And basically all we're doing with transformations is that we're taking it at pre-image, something you're starting with, and doing something to it to create an image. Now, there are several types of transformations: reflection, rotation, translation, and dilation. All right, so what we're going to study today is the translation and the reflection. So before we go into the depths of translations, let's go back to this page here. And there's a lot of stuff on this slide here that we need to know, and I'm not going to read all of it to you. But what I am more interested in is the rule up here. Let me kind of highlight this in red. It says a transformation maps the pre-image onto the image. That's just true in general. It doesn't matter what it is. But you always start with the pre-image and you go to the image. And down here below it, I'm going to do some highlighting here. It says the pre-image. The pre-image is the blue object, and that's this little triangle called ABC. And notice I got the word pre-image right there. And it's going to connect to the image, and that's this little orange object here. That's a translation. And what I'm more interested in make sure that we got down is that when you see the apostrophes, these little prime notations here, that's telling you that that's an image. So if you don't see those little apostrophes, that means you're dealing with the pre-image. At the bottom of the slide is a definition. It says an isometry is a transformation that does not change the size or shape of a figure. Isometry is just it's a one-word definition. And so down there is what it means. It's something it's a transformation that does not change the size or the shape of a figure. So when we go to the next page, there are three isometries on this page. And the three isometries are a reflection, a rotation, and a translation. Now, again, let's kind of make sure we explain that. These triangles are not changing size. They're not changing shapes. They're not changing from a triangle to a square or anything like that. It still stays as triangle. So same size, same shape. Now they're changing directions. Now they're changing the way that they're oriented. Sometimes they're flipped. Sometimes they're kind of rotated a little bit. Sometimes they're just moved, whatever. But they're not changing size or shape. So reflection, rotation, translation, those are isometries. Down on the bottom, the dilation, that is not an isometry. That's a similarity transformation. And we'll study that at the end of the unit. Now, when we get to today's lesson on the translation, all that is a slide or a movement. You're just taking all of the points and you're moving them in the same direction for the exact same distance. Now, that distance and direction is what is called a vector. And so when we go to the next page, I've got something here. I'm just going to box it for you. And it's three ways to express a vector. And you're going to cover vectors in much more detail in your physics class. All we're going to do is just kind of give you some absolute basics here. All right, so there's a ray. You can represent it as a ray, and there's two of them on this graph. So here's a ray going up and to the right, and then down here there's a ray that is going left and down. So those are two vectors on a graph. And we have two other ways. One is in component form and one is in rule form. And so I want to quickly kind of make sure I explain those. Now, when you see component form, if we go back to our definition here, and it says to translate a point along a vector, and I'm going to highlight this in blue, brackets A comma B. Now, this is not parentheses, it's a bracket. And so this is in component form. So if we go back to our notes, and we look at what's inside the brackets, here they are. What's inside the brackets are movements, horizontal movement first, vertical movement second. And so what this thing is saying is that we're going to move A units horizontally and B units vertically. And so that's where this comes from, and I've got this highlighted in orange. This right here in orange is the other form, which is called rule form. So it's x plus the horizontal movement and y plus the vertical movement. Now, the reason why I'm mentioning this, both of the forms, is because you will have test questions that'll ask you for both forms. And so let's go over one of them right here. So if we look at number 1 down below, it says, what are the coordinates of the image of A under x plus 2, comma y plus 1? And so let's make a connection here. This is in rule form. All right, so that means what follows x is the horizontal movement. That is a positive 2. And because that is a positive 2, that means it's going positive horizontally. And so what we need to remember is on our xy coordinate plane, when we move right, that is positive. So this is just a fancy way of saying we're going to go right 2 units. And so I'm going to try to scribble that in there. So right 2 units. Now, if we look at the vertical movement, that is y plus 1, since we're going positive in the positive vertical direction, that's up. And so that means we're going to go up 1 unit. And so to answer this question number 1, we're going to take A, here it is, and we're going to go right 2 units, up 1 unit, draw a dot. This is going to be our image of A, and we're going to label it A prime. And then all you're going to do to answer the question is give me the coordinates of A prime. So if you count spaces, it's 1, 2, 3, 4 to the right, 1, 2, 3 up. 4, comma 3 is the answer to the image of A. Take about 15 seconds, 30 seconds to take a look at questions 2 and 3. Once you get done with that, take about 30 seconds, a minute or so to tackle number 4 and 5. I'll be back with you in just a second. To answer questions 4 and 5, we need to kind of understand what we're physically asked to do. Now it says, what vector describes B, arrow, E? And so that means B is the preimage, E is the image, and so we're going to start at B. Let me get a arrow going here. If we start at B and we travel to E, this is our vector in ray form, but we want it, I've got it expressed 2 different ways, component and rule form. I'll take either one of the 2 answers since I didn't specify. And so what we're going to do is count spaces. If we're going to go to E, we're going to have to go right 3 units. And if we count spaces down, that's 1, 2, 3, 4, 5, 6, 7, 8. And so if we're going to go right 3 down 8, that gives us a component form of brackets 3 comma negative 8. Or if you prefer, you can write rule form as x plus 3 comma y minus 8. You'll do the exact same thing on question number 5. You're going to go from B to D. And we're going to see that we're going to go right and down to get from B to D. So that's why the answers are going to be similar to what you saw in question 4. All right, so that takes care of question 5. On the next 2 pages are just a wide battery of test level questions. Basically, this is it. I'm done teaching the stuff you need to know on vectors. You're just going to use the component and rule forms, the notes that I've given you here on the next few questions. So take about 2 to 3 minutes and start looking at some of the questions on the next page, and I'll go over the high points in here in a moment. Okay, here's your answers to questions 1 through 4 and the 2 parts of number 4. And what I want to do is just quickly kind of go over some of the things that I see are of importance. And so on number 1, it says, given the image and the dotted preimage. And so what we're going to do is we'll start at A, we'll go to A prime. I'm going to draw all of my ray vectors. And so here are all 3 of them. So that's my answer in ray form. Since we're going to go we're going to go right and up, that means my components have to both be positive. So it's a x plus 2 and a y plus 1. And it has to be in this form because, let me highlight this in blue, this form right here, the parentheses, is the rule form. All right, so if you did use the bracket form, the component form, your answer might be correct, but it's in the wrong form. So just make sure you give me the correct form. All right, question number 3, all you'll do is move your coordinates by right 4 down 2, and you should get the answers there. And when we take a look at questions, the last questions, the answer is D, and the component form is -2 comma -1. All right, so we will be, that's it for translations. I will come back to you with a new video on reflections. Thank you.